Hello everyone, myself Piyush Antandil, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. And the name of subject is Power System Planning and Design, which comes in fourth year, 8th semester. Right now we are discussing the chapter number 2, that is Design of Distribution System, and this is the module number 2.1. Now in this video lecture, we are going to see the electrical power system, then after importance of distribution system in electrical power systems, electrical power supply system, then after distribution system, and last topic, that is the type of distribution system. So starting with the electrical power supply system, generally the electrical power is generated at 11 and above, so we can call that generation of the electrical energy is normally at a 11 kV to 25 kV. Now step up transformer kept in power station to step up the voltage level, that is from the 11 kV to 220 kV, or we can also step up it to 440 kV. The transmission line transmit this power to long distance. This is called as a primary transmission line. So this is called as a primary transmission line. And a step down transformer, over here a step down transformer kept in receiving end station to step down this voltage level to either 66 kV or 33 kV depending on the requirements. And step down transformer is kept in substation at the end of this line, that is going to step down it from 66 or 33 to 11 kV line. This is called as a primary distribution system. Okay, so this is called as a primary distribution system, and this is called a secondary distribution system. And other 11 kV transmission line at receiving end is going to the different substations, or we can say pole mounted substation, where it is going to transmit, or we can convert it from 11 kV to further 415 kV for the domestic appliances. So this is how our power supply system is going to be work. First of all, the energy is generated at 11 kV, then after we are stepping up it, and then after transmitting it, so that is called as a primary transmission line. And at a primary transmission line we are converting it, at the end of primary transmission line we are converting it to 230 to 66 or 33 kV. Then after, this is at a receiving end side, so different substations require different power requirement and different voltage level. For that we can convert it from 66 or 33 kV to other desirable levels. Then after, this is called as a secondary transmission, where the 33 kV or 66 kV is transmitted to the other substations, and where it is going to be converted from 66 to 11 kV. Now from 66, while we are converting 66 to 11 kV, we are distributing this HT consumers. So what are these HT consumer? HT are the high tension consumer, which are like industries and different buildings and different companies who required 11 kV for their applications. So we are directly supplying 11 kV to these HT consumers. And for the domestic appliances, we are converting this 11 kV to 415 voltage, while these 415 voltage are directly given to the secondary distributors. Okay, I hope you get my point. Then after, we are going to talk next, that is the importance of distribution system in electrical power supply system. Now each and every component of electrical power system has its own importance, but the distribution system is slightly more important. Why distribution system is slightly more important? Because the important element of the supply system is consumer, for whom the power system is made, and this consumer receive the power through distributors. So from where the consumer are getting their power? From the distributor, and the distribution system is the most important term in our power supply system. Now distributor is also important from the point of view of law, because there should not be change of plus or minus 5% in voltage variable to consumer for the declaration voltage. So if we are declaring that the voltage level need to be 230 volt, at that time we are promising them that we are going to supply 230 plus 5%, only plus or minus 5%. Other than that 5%, the distributor may get some amount of penalty. So distributor have to be given the amount of power that is in declared voltage level. Then after next one, that is therefore the impedance of distributor wire should not be much. Moreover, the cross section of the distributor wire should be sufficient so that excessive heat is not produced in it because of the large amount of current that is going to flow from the distributor. Then after, at the same time, if the cross section of the wire is more, it increases the cost of distribution. And the distribution system should be reliable so that there is no interruption in power available to the consumer, or if there is an interruption, it should be possible to supply the power through alternative routes. Due to all these reasons, distribution is important in electrical power system. So these are the important factors that are going to be affect at a receiving end, or we can say consumer side, or the distributor. So because distributor is going to supply the load to the consumers. So we are going to see how distributor or distribution system is going to be behave. So this is how the distribution system is going to be look like. Over here in the middle of the figure we have S, that is the substation. Then after, substation is directly connected with feeder, and feeder is connected to distributor. So feeder are the intermediate link between substation and distributor, and distributor is the intermediate link between the feeders and the service mains. So these all are service mains. These all are service mains. Okay. The part of power system by which electrical power is distributed along various consumer for their local use is known as distributor. So these are the distributor from where we are directly providing our power to the service main. And in general, the distribution system is that part of the system which convey electrical power or energy from a major substation which are supplying the transmission line to consumers as per their requirements. And a low tension distribution system, that is this system which comprise of feeder, distributor and service main. Okay, we need to remember these three terms, that is feeder, then after distributor, and last one, that is the service main. Now if we are going to talk about the feeder, then a line or conductor which connects the major part of substation or localized generating station to the distributor. So what is the main function of the feeder? A line of conductor which connect the major substation to the distributor is known as a feeder, and feeder feed electrical power to the distributor. Now since no tapping is taken from the feeder, generally it carries same current throughout its length, so we are not providing any kind of tappings on feeder. The current carrying capacity is the main consideration taken into account while designing the feeder. So current carrying capacity is the main consideration while designing the feeders. Now if we are going to talk about a distributor, at a time a line or conductor to which various consumers are connected through service main is known as distributor, and it is to distribute electrical power, or we can say energy, among various consumers. Thus the number of tapping are provided on the distributor, as we can see over here, and that's why the voltage carrying capacity or voltage drop is the main consideration while we are designing the distributor, because we are connecting number of tappings, right? And last one, that is the service main. So what is the service main? A line or conductor or cable which connect the consumer to the distributor is known as a service main, and it is designed as per the connected load of the consumers. So this is all about the distribution system. Now we are going to talk about the type of distribution system. So there may be different classification, so according to nature, according to the construction, and according to the scheme of connection. So discussing about the first one, that is the according to the nature of current. So according to the nature of current, we have two different types of current, that is DC distribution system, and second one, that is the AC distribution system. Now second one, that is the according to the nature of construction. So construction wise we can divide it into categories, that is overhead distribution system, and second one, that is the underground distribution system. And according to the scheme of connection, that are three types, that is radial system, then after ring main system, and interconnected system, which we already studied in our ICPS subject, right? So if we are going to talk about first one, that is the according to the nature of current. we can talk about the DC distribution system. So electrical power is generated, transmitted and distributed as AC, normally as AC. But for some applications like DC motors, etc., it is absolutely necessary to convert AC power into a DC. Okay, we have several applications in a DC like traction system, because in traction system we are using DC series motor, right? So for that we need to convert that AC power into a DC power. For this purpose, AC is converted into a DC at a substation and it is distributed by two methods. That is, first one, that is the two wire system, and second one, that is the three wire system. So in again DC distribution system, we have different two types, that is the two wire system and three wire system. Now what is the two wire system? So in two wire system we have, this is the one cable and that this is the another cable, right? So from this cable our power is going from this side to load to return part. Okay, so to return part, so this is the flow of current, how current is going to be flow from this load, motor or lamp, whatever the load, we are connecting in between these two lines, and voltage V is applied in between these, or we can say voltage V is withstand between these two lines. So between these two lines we are going to connect our system. That's why we are using only two wires, so we can call this system as a two wire DC distribution system. Now talking about the three wire system, three wire DC distribution system, it consists of three wire, two outer wire, that is this wire, and we can call this wire, and one center, that is it can be positive and negative, and center wire is called as a neutral wire, and which may be earthed at a substation. Okay, now the the voltage between any outer and neutral, that is going to be V. So if we are considering the voltage between 0 and minus, that is also V, and considering the voltage between plus and 0, that is also V. Whereas the voltage between two outer is the twice of that, that is outer two conductor voltage, that is this V plus this V, it is going to be twice V. Okay, so the voltage between outer conductors is going to be twice V, and thus two voltage are available for the consumer, that is this V and twice V, these two different voltage level that is available for the consumer. Now the lamp load or low voltage load are connected between any one outer and the neutral, whereas the motor or high voltage load is connected in between two outer cables. The current flowing from the neutral is very small, only unbalanced current, which will be zero when the load is balanced. Okay, and therefore generally area of cross section of the neutral cable is taken as a half as compared to the outer cables. Okay, because there is very much of less amount of current that is going to flow from this neutral conductor. This is all about the three wire DC system, because we are using three wires. Okay, so next one that we are going to talk about, that is the AC distribution system. We have completely seen the DC distribution system, right? In DC distribution system there are two types, that is two wire system and three wire system. Now we are going to talk about the AC distribution system. So normally we use alternating current for generating, transmitting and distribution of electrical energy. We use alternating current due to the fact that alternating voltage can be easily stepped up or stepped down in magnitude by means of transformers. This characteristic cannot be achieved by DC system. So the AC distribution system is classified into the two categories. That is first one, that is the primary distribution system, and second one, that is the secondary distribution system, right? So we are also going to see both this primary and this secondary distribution system. So from the power station, power is usually transmitted through high voltage transmission line at we can consider as a 33 kV or 33 kV to 220 kV, right? At this substation voltage is stepped down to 11 kV. So over here we are converting this 33 kV to 11 kV, and that is directly going to fed to the consumer side. So from this dotted line we are going to call this line or this portion as a primary distribution system, and this system is known as a primary distribution system. Now voltage used for the primary distribution system depend on the power to be conveyed and distance of substation required to be fed, distance of the substation that required to be fed. So from the point of view of economy, primary distribution carries three phase wire only. We are not having four wires over, only we have three wires, that is three phase three wire system. So for the big consumer, that is like factory, we are directly providing 11 kV that is also three wire system, three wire three phase system to the factories, or we can say big consumer or HT consumer. Then after this three phase three wire is also directly going inside of the different subsystem located at different sites, right? So this is called as a primary distribution system, where we are feeding our 11 kV voltage to big consumer and substation. Now secondary distribution system, at a distribution substation voltage is kept down to 400 volt, right? So over here we are converting from 11 to 400 volt. From this station voltage is at a low level, that is 400, and between phase we can call 230 volt. Okay, between phase we can call 230, and between two phase we can call it as a 400 volt, and that is distributed directly to the consumers. Now this system is known as a low voltage or secondary distribution system. So from this portion we can call this as a low voltage or secondary distribution system. And we can see that we have over here three wire on the primary side and four wire on the secondary side. So for the secondary distribution system we have the system of three phase four wire, where the neutral is also considered. A typical secondary distribution system is shown: the primary distributor delivered power to the distribution substation, where the three phase delta star distribution transformer step down the voltage level from 11 kV to 400 kV, 11 kV to 400 volt. The low voltage secondary, that is single phase domestic load, are connected in between one phase and one neutral. As we can see, this house 3, 1 and 2, these are connected between phase B and neutral, this is connected between phase Y and neutral, and this is connected between phase R and neutral, while the factory that is directly connected with the three phase 4 wire loads. Okay, so this is called as a secondary distribution system. So this is all about the AC and DC distribution system. Now we are going to talk about the second consideration, that is according to the construction, or we can call it as a difference between overhead system and underground system, that is based on its construction. So appearance of overhead system is not good due to the overhead wires, insulators, jumpers, cross arms and etc. That is the disadvantage of the overhead system, while in the underground system the wires etc are not seen, so the appearance is good. Maintenance, so maintenance is more, as the live wire, insulators etc are open, that is also very disadvantage of overhead system, and maintenance is less as the cable is undergrounded. That's why this is the advantage of the underground system. Then after possibility of fault, as the conductor are in open, possibility of fault occurrence is very much of more, while possibility of occurring fault in the comparatively less as the cable is undergrounded. So this is also advantage of underground cable. Now safety, that is the safety is less as the wire may break and cause harm to the living beings, and in the underground system there is more safety because we have underground cables. That is also advantage of underground system. Now possibility of lightning struck, that is the more, because it is directly exposed to the environment, while the possibility of lightning struck is very much of less because it is buried underground. Next one, that is the voltage drop. As the spacing of the wire is more, the inductance is more, so the voltage drop is more due to the inductive reactance. That is the disadvantage of overhead system, while inductance is less due to the closed conductors, so the voltage drop is very much of less due to the inductive reactance, and that is the advantage of underground system. Now disturbance to the nearby communication line, so possibility is more, transpose of line is done to reduce it, because in overhead system that is going to disturb your nearby communication line, and to reduce that effect we are going to transpose our transmission line, and there is no distribution is caused inside of underground systems. Fault location and repairing, that is the fault location is very much of easy, and the repairing is also very much of easy, that is the advantages of the overhead system, while fault location is not easy and repairing is very difficult for the underground system. And capital cost, that is overall capital cost is very much of low, even though the cost of supporters are more, and capital cost is more because we are using the cables. That's why the capital cost of underground system is very much of high. Last, that is the working voltage. So overhead line are used up to the voltage that is more than 400 kV, that is the advantage. And for the underground, not used for the high working voltage, because the size of the cable, or we can say cross sectional area of the conductor, is going to be increased, so we need to provide more insulation to the underground cables. That's why this is not the advantage, or we can say we cannot use high voltage for the underground system. Next one, that is the flexibility. So flexibility is more, and changes are very much of easy, because we can easily change the, or we can say molded our overhead transmission line, while flexibility is changed by making the difficulties in underground system. Now capacitance of the line and charging current, that is capacitance is less as the spacing of the conductor is more, so the charging current is very much of less, that is the advantage. And as the conductor are nearer, the capacitance is also more, so that the charging current required for the underground cable is more. And wire joint, taking tapping by wire joint is very much of easy, and it is very much of difficult for the underground system. So this is the difference between overhead system and underground system. Next we are going to see the connection scheme of distribution system. So distribution system can be classified according to the scheme of its connection that we already seen, that is the radial distribution system, ring vane or loop distribution system, and grid or interconnected distribution system. Let's take a quick overview on these all the things. So in radial distribution system, what's going to be happen over here, we have the primary distribution system or primary distribution substation, that is going to be connected with different types of loads. So we have circuit breaker first of all, then after we are going to take the tapping, that is the secondary distribution system, that is going to convert this 11 kV to 400 voltage. Again over here we are converting 11 to 400, 11 to 400, and so on and so forth. So we only have this one circuit breaker over here, that is in between this load side and this 11 kV distributor side. So that's it, that is the radial. Inside of the radial only one single path is available for the power supply, that's why it is called as a radial distribution system. Now second one, that is the ring vane or loop distribution system, where we have this loop type or we can say ring type. That's why we are calling this as a ring vane distribution system, where we have two different parts, that is circuit breaker over here and two circuit breaker over here, and this is the other main bus from where we are going to get our power, that is 11 kV to 400 kV we are converting at a consumer side. Now if fault is going to be occur on this bus, at that time this bus is going to be in active mode, so all the power is going from this side to and feeding all the loads. So the continuity of power supply is going to be maintained inside of the ring main or loop distribution system. Next one, or we can say the last one, that is the grid or interconnected distribution system. This is the more advantageous and most suitable for distributing the power, because we have different buses, that is 11 kV buses over here, 11 kV buses over here, and last one, that is the 11 kV buses over here and over here. So we have different 11 kV buses from where we can connect our loads. So whenever any kind of fault is going to be occur on this line or this line, the power is going to flow from the other part, and here the boxes are indicating the different circuit breaker that are available, and that is going to be isolate the system when fault is going to be occur in between. So for that, whenever the fault is going to be occur in between these cables, at that time circuit breaker is going to be isolate this portion, and the load is also going to be fed from the other part. Okay, load is going to be fed from this path, or we can call it as this path. If this part is faulty part, then the current is going to be fed from this part only. So continuity of power is going to be very much of increasing order inside of the grid, or we can say interconnected distribution system. Now here are the important questions that are already asked in GTU examination, like explain the distributor system in details. That can be asked for the 4 marks. Then after explain 2 wire and 3 wire distribution system, that can be asked for the 3 marks. Then after explain the primary and secondary transmission in details, that is going to be asked in 4 marks. That is the AC distribution system, right? So primary and secondary is the AC distribution system, and you have to write and draw the figure of primary and secondary distribution system or transmission system. Next, compare the overhead and underground system, in which we have already covered lots of topics or lots of points that you have to write down in your answer sheet, and the question may be asked for the 7 marks. And last one, that is the explain radial distribution system, ring main distribution system, and grid distribution system, in which we have to draw the complete single line diagram of the radial, ring main, and grid distribution system, and explain each and every one in detail. That may be asked for the 7 marks. That's it for today's video. And if you find any kind of query regarding this lecture, then please feel free to ask me. Thank you.